Today we're talking about Terminator, the legendary film by James Cameron, which has captivated the big screen and the collective imagination of millions of people. We'll take a look at the iconic Terminator, a cyborg built to be virtually invincible, and discover whether its technology is just a product of fiction or if, in some way, it could become part of the science of the future. Throughout the video, we'll explore the concepts of artificial intelligence, advanced robotics, cybernetics, and futuristic weapons to understand how much of what we see in the film could one day become a reality. Is it really possible to build a machine like the Terminator? And if so, how far are we from creating similar technologies? Welcome back to the Science of the Future. Let's start by talking about the Terminator T-800, the one played by Arnold Schwarzenegger, which is indestructible and has a built-in visor in its eyes that allows it to lock onto targets and gather information. It can even travel through time. Is this scientifically possible today? So, the robot tends to get stuck and usually makes mistakes quite quickly, just like the humanoid robots we've already talked about on this channel. If you're interested in the video, click on the top right. Now, legs are the least effective thing in the universe for movement. No one would build a robot with legs, yet they build them, but only for the love of science fiction. Robotics has something incredible that no other science has. Robotics was born in literature, and it all started with Isaac Asimov. The first word robot was coined in 1921, and robot means slave, as if they were our slaves. But the first robot was built 40 years later. In the 1960s, we started building robotic arms that could only move things. But since we love science fiction, we began creating humanoids. Essentially, a robot is a programmable machine capable of performing a task autonomously in place of a human. The difference between a robot and a computer is that the latter always requires input from humans and cannot interact with the external environment. A robot, on the other hand, has sensors that can observe the surrounding reality and adapt it to its needs. For example, in a robotic arm, the sensor records the grip on the object. When it detects resistance in the current, it will grasp the object. Then there are some very fun things, like the Robot Soccer Championship, the Robot Soccer World Cup. There is a competition between major universities. In Italy, we even have a national robot soccer team. The championship is all about the ability to program them. It's quite funny because they miss the ball and fall down on their own. It's a little game, but very complicated. However, a robot that walks on its own legs is not efficient. For example, on Mars, rovers almost always have 6 wheels. Not tracks, but wheels. And they have very rigid wheels, unlike car wheels. This is because on Mars, if a rover falls, it's not easy to lift it back up. The Terminator's vision makes a lot of sense from a scientific point of view because there are some robots that see by difference, meaning they detect movement. When an object moves, they notice the variation in the image. They are able to reconstruct the movement. So the vision system is realistic. But in Terminator 2, he has systems that recognize objects. That, in fact, is artificial intelligence. A standard image recognition system, not particularly complex, is capable of doing that. In the film, the artificial intelligence system draws a border around objects. But in reality, they usually draw a rectangle. They detect where an object of that type might be and assign different colors to different categories of things. For example, self-driving cars, which are essentially robots, do exist, work, and perform very well. They have some issues, but overall, they function. These systems recognize other cars, vehicles of different kinds, trucks, bicycles, and pedestrians. But is the industrialization of Terminator possible? No, not across the board. And the least plausible thing is that fire would immediately destroy robots. It's like a computer that instantly melts. In fact, in the second film, they cook the Terminators in extremely high heat to destroy them. How far are we from having humanoid robots that walk, use stairs, and even do the cleaning? Well, we've made a lot of progress, but they still don't have fully functional legs. For example, there are experiments in museums where robots guide visitors around, saying things like, "I'd like you to see this, follow me," and they take you on a tour. There are also trials in hospitals to provide assistance, which is one of the hottest areas in robotics right now. The population is aging rapidly, so how will we take care of the elderly if there are not enough young people? Studies show that it works very well with the elderly because they have less difficulty interacting with a robot than with a real person. They have fewer concerns because if it depended on a human, it would be a bit sad. Now let's talk about the second version of the Terminator, the T-1000, the Team Leader. It's essentially the same thing, but with one difference. The T-1000 can liquefy. It turns into a puddle of liquid, slips through locks, bars, and gaps, and then reassembles itself. Is this possible today? Well, there are some things that make sense. Liquids that move and reassemble into different shapes can be made. Think of slime, but ferromagnetic, meaning it responds to magnets. With a series of magnets, you can move this substance, which seems to move like a robot. It's like when you see droplets that then reassemble themselves, and that can be done. There are even ongoing experiments, especially in the medical field. To control pills, for example, you could swallow a ferromagnetic tablet that contains all the active ingredients needed to target specific areas, and then use a magnet to guide it to the right spot. But it's not a robot, because a robot still needs a CPU or a motherboard, which cannot be made liquid, so you'd need a CPU for each unit. Today we have small robots that work together in this way. This idea of liquefying and then reassembling is part of a branch of robotics that studies this phenomenon, known as swarm robotics. So, we take many small robots that can do just a few things, and we make them work together. They are programmed as if they were independent entities, but they cooperate. This concept exists. For example, researchers have built robots as small as a 5-cent coin. These robots can only vibrate and have a light sensor, so they move towards the light. If we create a maze on a table, place a light in the middle, and the walls cast shadows, the robots will move through the maze towards the light. In the future, robotics could be used to build temporary structures. For example, imagine an emergency in the desert. You need a base to perform a critical operation. You send a group of small robots, like bricks, that move and organize themselves to form a dome in which you can enter. They actually build the structure themselves. This is where the line between physics and robotics blurs, because it involves the physics of complex systems. Each robot is programmed to perform simple tasks, but together, they can accomplish much more than they could individually. In Terminator, the robot divides itself to pass through bars, and in the near future, this concept is almost plausible. Now, let's see if Skynet, an artificial intelligence built using a neural network, is really that dangerous. But is artificial intelligence really that dangerous? Can it gain consciousness? No, because the base of artificial intelligence is that it is extremely limited. It is called intelligence because it sounds good in the media and works well as a headline. But what can it really do? Almost nothing. It can't even draw. And if you ask ChatGPT, it's pretty much zero. It's called intelligence because of its history and the algorithm behind it. The engine that opened this world is the neural network, which simulates the functioning of the brain. Our brain works with neurons that exchange information and operate through action potentials. Artificial intelligence, AI, acquires data through various methods and techniques. And the quality of this data is crucial in determining how well AI can perform a specific task. Here's a detailed look at how AI collects, processes, and uses data. Data Sources AI collects data from a variety of sources, including structured data. These are data organized in tables, databases, spreadsheets, etc. The data is in a format that is easily readable by a program and is generally numerical or categorical, e.g., data sets containing sales, dates, product categories, etc. Unstructured data. This refers to data that is not organized in a predefined format. Examples include text, images, audio, and video. Most of the data on the internet is unstructured, and this is where advanced techniques such as natural language processing, NLP, and computer vision come into play. Semi-structured data. This is data that is in between structured and unstructured. Examples include JSON, XML, or log files. These data types contain tags and metadata that help organize the data in a partial manner. Second, data collection methods. AI collects data using different techniques depending on the application. Automated data collection. Web scraping. When AI needs to gather data from the internet, web scraping tools analyze the content of websites to extract structured information. This method is used to collect real-time information from online sources, such as articles, reviews, and social media comments. Sensors and IoT devices. Physical devices such as sensors, cameras, and microphones can collect data from the real world and send it to AI systems for processing. For example, in autonomous vehicles, cameras and sensors collect data on the surrounding environment. User-generated data. Modern AIs also collect data directly from users. For example, platforms like Facebook, Instagram, or Google continually gather information on user behavior, such as clicks, searches, interactions with content, and geolocation. Simulated data. In some cases, the data isn't real, but simulated in a controlled environment. This is common in training robots. For example, a robot might be trained to navigate through a simulated environment before performing the task in the real world. What's similar today? Advanced bipedal robots. There are robots like Atlas by Boston Dynamics that can walk, run, and perform acrobatic moves. These robots are incredibly agile, but they don't have the strength or independence of Terminator. Autonomous weapons. There are already armed drones and military robots, like the Mars developed by the US Department of Defense, which can be equipped with weapons. However, they are controlled by humans and do not operate independently like the Terminator. Artificial intelligence, AI is making huge strides, with machines capable of recognizing faces, analyzing behavior, and making decisions in complex situations. However, they are not yet at the point of independently acting like a Terminator, which can make ethical and strategic decisions on its own. In the future, robots like Terminator could become a reality, but with many limitations and ethical and legal regulations. Research into advanced artificial intelligence, robotics, and autonomous weapons is ongoing, but there's also significant concern about the safety and control of these technologies. In short, a Terminator as we know it in the movies? Not yet. But the road is long, and the future might surprise us. Don't forget to subscribe to the channel and leave a like. That's all for today. And especially if you see a T-800 on the street, run.